So what I want, everybody, and welcome back to Jumanji. So this one goes out to all the lab partners that used to say, girl, you do the computation and I'll get started on the measurements, right? Me included. But anyways, to convert from volume to mass of your cyclopentadiene, we're going to use a formula for density. But we're going to rearrange it so that mass is now equal to your density, which is a known value, times your volume, which is given in the problem. Mass is then equal to your density for cyclopentadiene, which is 0.081 grams per centimeters cubed, right? And you multiply that by your given volume, which is 6.00 centimeters cubed. We added the two zeros at the end because the problem says two significant figures after the decimal point. The centimeters cubed will cancel each other out. Units will be in gram. Once you multiply out, your mass use of cyclopentadiene will be 4.86 grams, right? Now, to figure out your limiting reagent, we need to convert both cyclopentadiene and maleic anhydride from grams to moles. And to do that, we're going to divide them by their respective molecular weight. So for cyclopentadiene, we have 4.6 grams, right, as your mass. The molecular weight of cyclopentadiene is 66.10 grams per mole. Again, two significant figures at the decimal point. Your grams will cancel and your value for moles will be in moles. Once you divide, you'll have moles of cyclopentadiene, right? We'll do the same for maleic anhydride, except we're using 6 grams as in the problem and using its molecular weight to divide. So we have 6.00 grams of the maleic anhydride. We're dividing that by its molecular weight of 98.06 grams per mole. Your grams will cancel each other out, leaving you with moles as a unit for moles. Right? Once you divide, you'll see the moles of maleic anhydride. Alright, so for your maleic anhydride, you have 0.061 moles compared to 0.073 moles of your cyclopentadiene. Even though you're using less grams, less mass of cyclopentadiene, your moles are still more. Therefore, your limiting reagent will be your maleic anhydride, right? Which just says your reaction is limited by this moles of your reagent. Once this moles is used up, your reaction is completed in theory, right? So this leads you to your theoretical yield, which says if all of your moles of your limiting reagent is used up and you get 100% of your product in theory, how much would that be? So you're going to take your limiting reagent, right? You're multiplying your limiting reagent by the molecular weight of your product, right? You can add maleic anhydride's molecular weight to cyclopentadiene molecular weight for the answer, or you can just do it the long way. Either way, your answer will be your limiting reagent, this number, multiplied 164.16 grams per moles. It's molecular weight for your product. Your moles will cancel. Unit will be in grams. You multiply out. Your theoretical yield is 9.85 grams. Now to get your percent yield, you take your theoretical yield, put it at the bottom, put your actual yield at the top, what you actually get after your experiment, which is 8.20 grams, and you multiply this number by 100. So your actual yield over your theoretical yield multiplied by 100% gives you your percent yield of 83%.